Welcome you all to the video lecture of computer architecture, session number 5. So here in this session we are going to discuss to the topic related to the instructions and the sequencing. So before to the top session we discussed regarding to the top memory location and the operations of a memory. So here the instruction and sequencing is been discussed in detail. So instruction sequencing. So here this instruction and sequencing related with respect to our normal computer system says us that whenever we are going to execute a program in our machine, which means that there a sequence of an instruction is required. A sequence of what instruction is required, that instruction will going to be get interact with that machine. So this instruction is what the machine understanding language, which means that machine instruction. So automatically this instruction performs the arithmetic operations or any operations such as transferring data, performing those logical operations and testing the conditions and get interacting, which means communicating with those IO devices, so input and output devices. So normally this processor will execute those instructions in a sequential manner, sequentially executing those instruction in order to accomplish what that desired task which we have been mentioned over there. So from this we can able to say that those computer program is mainly in order to get sequencing those instruction in an order in order to get stored in a memory. Simply we can say that an ordering of sequence of instruction to store in a memory, and after that we need to execute by the processor. So this is the main thing has been said in the instructions and the sequencing. So after to that the types of processor operations are going to discuss here. So here these types of the processor operations were majorly related to the first category of a data transferring. So whenever, which means that the processor must support in order to these four fundamental major categories of operation. The first thing is what the data transfer. So data transfer is the first category. Here from this word you can able to say moving of data between the memory location, processor registers, which means the general purpose register, and IO devices. So the next thing is of what the second category deals with the arithmetic and logical operation, ALU operation. Here the addition, subtraction, and the multiplication, comparison of boolean operations will get been processed. So the third category is what means the program sequencing and control. So program sequencing and controls were being determined for what in order to executing those instruction which we have discussed over here, the sequencing instruction, machine instructions. So those things has been fetched over in this program sequencing and control in order to get determined over the execution order of those instruction by making a looping mechanism or a branching mechanism. So those final category is IO operation, which means that enabling of communication between the processor and peripherals. So together accomplishing these four operations, we are going to get consecuting what an instruction set architecture for a processor. So the next we are going to need to get a clear picture over to this RTN, register transfer notation. So this register transfer notation is mainly for moving of data, which means that internal movement of data across or within a computer system, majorly represented with respect to that of RTN, register transfer notation. So from this square bracket of R2, which means that the location LOC will gives us to the top R2, indicates mainly that the content stored in the memory location LOC are transferred over to the processor register R2. So similarly here the R2 and R3 register transfer over to the top where R4, which means that the right hand side of an RTN expression, which specifically says us to the top what the source operands, whereas the left hand side specifies what the destination register or a memory location. So this is the terms has been said in the RTN, register transfer notation. So the next is the assembly language notations. So here this assembly language notation majorly says us regarding to the top symbolic of representation to the top machine instruction. So symbolic representation to the top machine instruction is saying with respect to the rough assembly language notations. Here this load R2 LOC and add R4 R2 R3 says with respect to this of assembly language notation. Here this load R2 LOC automatically transfer the content of memory location LOC into the processor which has a register of R2. Here no modification, which means that without modifying the content of the memory location. So parallelly, which means here this add R4 R2 and R3 perform same arithmetic additions using the contents of registers R2 and R3, storing those added, which means that computed result value over to the top register R4. So here this AL notation, which means that assembly language, simplify those programming processor by replacing those with respect to that of binary machine instructions. So with respect to that of binary machine instruction, this assembly languages will be get simplified in order to for a readable mnemonic with with maintaining of one-to-one correspondence with respect to what the hardware operations. So the next is the RISC-CISC instruction set architecture. Here the reduced instruction set computer and the complex instruction set computers majorly employs with respect to the following things. Here there is employs what? A reduced number of simple instruction. RISC is what means a reduced number of simple instructions. So here the simple number of simple instruction each will be designed from where efficient execution things as such as a simple clock cycle with respect to simple clock cycle, whereas this CISC is direct contrast with respect to that of RISC, which means that it is a reduced number of simple instruction has been mentioned over in RISC, whereas in CISC architecture provides the large number of complex instructions. Here there reduced simple instruction, here the complex instructions has been mentioned in CISC. So these complex instructions can be capable of performing the multi-level of multi-low level operations within a single instruction. So the primary objective regarding to that of RISC and CISC is RISC is simply we can say that the processor hardware and improving the execution speed has been done over in RISC, whereas in the CISC the main motto, which means that the main aim of this CISC is to reducing the program size in order to by minimizing the number of instruction in order to perform over a task required for a task. So the next thing is the characteristics of RISC architecture. Here this RISC characteristic has been deals over with respect to load and store architecture. So which means the fundamental characteristics of RISC architecture deals is with respect to this load and store architecture, whereas this memory operands were not been get participated. So memory operands is not get been involved over in the process of ALU arithmetic or any logical operations. Instead they are using the data must be the first to be get transferred from where memory to processor. This is the thing which need to get transferred from memory to processor. So process register with respect to that of load instructions, whereas in that the arithmetic and logical operation are then performed exponentially or exclusively onto the top which operands, the register operands, they will be executed. So after that the computation, which means that after computing those things the results has been transferred where to store instructions. So memory and store instructions, these are the major things that has been get involved over to the top the characteristics of the RISC architecture. So now we can see with respect to that of executing how they are executing these arithmetic operations. So now we are going to get considered an example C is equal to A plus B. Here the first the operands were need to get stored over to where memory location of A and B. Those location A and B are now need to transfer to the processor register using the instruction of what load R2A and load R3B. So these instructions is with respect to that of add R4, R3 and R2 will compute the summation of those two operands. So here these two operands has been performed with respect to this third instruction add R4, R2 and R3. So automatically finally those instruction has been stored where in the R4 register. So final result of C is equal to A plus B has been get executed. So this sequence illustrates the things of fundamental things is need to get perform over to load execute store operation involved in the RISC architecture. So the load execute, which means the load execute and store operation of or by RISC processor. So the next thing is the optimizing those things, those registers usage. So optimizing here says us to the top, reducing usage or minimizing the level of storage of using those registers. So now with respect to that of instructions of add destination source 1 comma 2 and store source comma destination. So these things is here this add is a 3 operand or a 3 by address instruction formation, whereas the source store instruction has a 2 things is often get involved. So with respect to this, now this store R3 comma C and add R3 R2 and R3 will automatically stores us the results directly into the which register R3 register. Followingly this store R3C will transfer what the results to memory. So the results will be transferred to memory with the help of the second instruction store R3 comma C. So this approaches will automatically minimizes what optimizes the register utilization, general purpose register utilization with while performing with respect to that of computational correctness and improving the what register allocation efficiently. So these are the things is, so load R2 and A, load R3A add. So those things has been diagrammatically represented here. So the next thing we are going to need to see over what the instruction and sequencing. Here the processor automatically execute with respect to what instructions in a sequential manner under the control thing of a what which program counter. So the program counter will do the sequential order with in order to get execute those instructions into the processor. This will automatically stores what the address of the next instruction. So PC is nothing that it will stores the address of the next instruction need to get followed over to the top processor execution. So normal during the normal time of execution these instructions were being get fetched or get from the memory. After that decoding and executing process will be get processed over here. So normal proper instruction sequencing will get ensure the correctness what the program execution but to maintaining those intended order of operations and in order to get preserving or need to get preserve data dependencies across the good successive instruction execution system. So from this video lecture we can able to get knowledge over to what are the things is RISC architectures, CASC architectures, how the data has been loaded and stored over to the top memory things as thank you.